Hi students, today we are going to see the problems on power and torsion. Okay, so basically power is equals to 2 pi nt by 60. Okay, power should equals to 2 pi n into t by 60. Here torque is Newton meter. This is a mean torque. Okay, this is the mean torque or average torque. Average torque, this one is average torque. Okay, not the maximum one, it is the average one. N is rpm. We all know that rpm means revolution per minute, and power is in watts. Okay, power is in watts, not kilowatts. Remember these units. P equals to watts, power watts, torque in newton meter. That is an average one or mean torque. Okay, so we will see the problem on these two relations now. So see the problem here. Find the maximum shear stress induced in a solid circular shaft of diameter 15 centimeters. So it is a solid circular shaft of 15 centimeter diameter when the shaft transmits 150 kilowatts power at 180 rpm. So write down the given data. First of all, the diameter will be 15 centimeters. Okay, diameter will be 15 centimeters, and rpm will be 180, and power will be 150 kilowatts or 150 into 10 to the power of 3 watts. Okay, kilo means 10 to the power of 3, we all know that. So now by using this equation, by using this equation, we substitute whatever we have here, we will get t average. Okay, so we will find the t average. So here we will see 150 into 10 to the power of 3 equals to 2 pi n 180 by 60. Okay, this will be t average. Okay, this will be t average. So then t average will be 7957 7957.7 7957.7 Newton meter. Okay, this is Newton meter, t average. So then we will convert this into Newton mm. If we place 10 to the power of 3 here. Okay, 7957 into 10 to the power of 3, we will get Newton meter. I will write that one. 7957.7 into 10 to the power of 3 Newton mm. Okay, t average. So now we all know that t by j equals to tau by r. Okay, t by j equals to tau by r. This is the torsion equation. From this torsion equation, if we substitute all the values which we have got here, that is this diameter 15 centimeters and this t average. Okay, if we substitute diameter 15 centimeters and whatever the value t average we got here, we substitute this here, we will get the tau shear stress value here, whatever the required term here, shear stress, right? Whatever the required term shear stress, that we will get here. So that will be t by j. So that will be 7957.7 into 10 to the power of 3 by 5 by 32 d power 4. So what is d here? Diameter will be 15 centimeters. Okay, 15 centimeters in the sense, we take this in mm, this will be 150 power 4. So that is equals to again d by 2. So you can see, we can find easily tau here. So the unknown term in this equation is only tau, so that will be 12 Newton per mm square. Okay, so this is a basic problem based on power and a torque. Okay, based on the relationship between power and a torque. This is the basic problem, and we are going to solve another basic problem based upon power and torque. So this is the problem. You can see here a hollow shaft of external diameter 120 mm transmits 300 kilowatts power at 200 rpm. So here you can see it is an hollow shaft 120 mm external diameter. It transmits 300 kilowatts of power and 200 rpm. Determine the maximum internal diameter. So here we need to find out the internal diameter of the hollow shaft. If the maximum stress in the shaft is not exceeded 60 Newton per mm square. So here the maximum shear stress is 60 Newton per mm square. Okay, maximum we cannot exceed 60 Newton per mm square, and then we need T value here. Okay, we need to find the T value here, and then we have outer dia 120 mm, and it is transmitting a power of 300 kilowatts. Okay, and at an rpm of 200. Okay, at an rpm of 200. So now as usually write down the power equation. First, P equals to 2 pi n t, okay, by 60. So if you write power here 300, convert this into kilowatts. 10 to the power of 3 equals to 2 pi n is 200 by 60. Okay, by 60. So this will give us the value of T here. So the T will be 28647.8 Newton meters. Okay, remember this. If you substitute power in watts, you will get torque in Newton meter. Okay, you will get torque in Newton meter. If you substitute power in watts, you will get torque in Newton meter. Then we can convert this into Newton mm if we substitute 10 to the power of 3 here, and then our torque will be T equals to T by J equals to tau by R. We can simplify this equation. I will write the simplified equation now. T equals to tau by d by 2 into pi d outer power 4 minus d inner power 4. Okay, d outer power 4 equals to d inner power 4. So in this equation, if you observe this one, we will have only one unknown, that is this d internal. We have tau. You can see we have torque T here, and we have tau shear stress here. We have D, that is D outer. We have D outer here, and we only want this one. So substitute everything here. So that will be if you substitute everything, you will get the answer here. Okay, the answer will be D equals to 122 n. Okay, substitute everything and find the answer 122 mm.